Hello, so we're into Unit 10. Unit 10 is going to have only one new topic, truth table analysis of arguments. And other than that, we'll just be continuing with Chapter 2, symbolization and derivation. And in the next unit, and for the rest of the quarter, we'll be in Chapter 3, where we expand the language again. And when we expand that language, our language gets substantially more complicated. And so it turns out that there's actually a lot to do with that new language. But for this unit, we'll just be continuing with Chapter 2, derivations and symbolizations. I'll be doing a couple of problems for sample problems in videos. Other than this, I'll do some truth table analysis actually using the truth tables in another video. And in this video, I'm going to spell out how we evaluate arguments using truth tables. So first thing we want to remind ourselves is of our definitions of validity. So here we have that an argument is tautologically valid. We'll talk about why we're saying tautologically later in Chapter 3. But for now, we can think tautologically valid or valid and not worry about the difference. So when is it tautologically valid? Well, if the conclusion is true in every situation in which the premises are true. So if the conclusion is true, then no matter what, the premises are also true. And another way of saying that is that there's no situation in which the premises are true while the conclusion is false. Those are equivalent ways of saying the same thing. So if premises true, then no matter what, conclusion true, or there's no situation in which true premises, false conclusion. So we can think of validity in terms of counterexamples. We can think of that a counterexample to an argument's validity is a situation where we have true premises and a false conclusion. And so then if we find on a row of a truth table that the argument has true premises and a false conclusion in that situation, then we have a counterexample. On the other hand, if a row has a false premise, it's not a counterexample, right? It's missing one of the two requirements. To be a counterexample, the row has to have true premises and a false conclusion. So if the row has at least one false premise, it's not a counterexample. Again, if a row has a true conclusion, it's not a counterexample, right? Pretty clearly. So to have some examples, let's look at this first row, this argument. So suppose that on this row we have so our argument is P, P or R, R. On the first row, we're not going to look at all the rows for this table, but on the first row we would have P is true, and P or R is true, and R is true. So this row is not a counterexample because the conclusion is true. And so it's not a case where we have true conclusion, false premises. If we look at the bottom row, we have that P is false, P or R is true, and R is false. So is this a counterexample? It's not, because P is false. And so again, it's not a case where we have true premises and false conclusion. We do have a false conclusion, but to be a counterexample to the validity of the argument has to have also all true premises. Remember, that's a different way of saying if the premises are true, then the conclusion is true. Well, this isn't a counterexample to that because it's not a case where we have true premises. Now, if we look at this middle row, we have that P is true and P or R is true, but R is false. And so on this row, we do have a counterexample because we have all the premises are true and the conclusion is false. So that's what you need for a counterexample. So an argument is valid if and only if it has no counterexamples, right? It's valid if and only if the premises are true, so is the conclusion, which is the same way of saying there's no situation in which the premises are true and the conclusion is false, and that's a way of saying there are no counterexamples. So when we're thinking about validity and using truth tables, you want to think in terms of counterexamples. You're looking for counterexamples. If you do find a counterexample, the argument is invalid, and you know it, and you don't need to do anything more. If you don't find a counterexample and you survey the complete truth table for the argument, then there are no counterexamples and the argument is valid. So that's the way we're thinking, looking for counterexamples. If we find one, we're done, it's invalid. If we look enough and we don't find one, then we're done and the argument is valid. So in particular, suppose you find a row with true premises and a false conclusion. Well, that means you have a counterexample, and that means the argument is invalid, and you're done with the argument. You now know it's invalid. If you find a row with a false premise or a true conclusion, either of those, then you know it's not a counterexample row, and you don't need to worry about the rest of the premises or the conclusion once you find out that it has either a false premise or a true conclusion. and you're done with that. That means you're done with that row, and you move on to the next row. And if you finish all the rows without finding a counterexample, then the argument is valid, and again, you're done. So the way this works is you're going to say, I'm looking for counterexamples. If I find one, good, argument is invalid. If I don't, good, argument is valid. What is it for a row to be a counterexample row? All premises are true, conclusion is false. Once you determine that any of the premises are false or the conclusion is true, you're done with the row, you know it's not a counterexample, and you can move on. So you might ask, where should I start? Well, wherever you most easily determine whether or not a row is a counterexample. If you say, oh, here clearly the row is a counterexample, do that, and then you're done. If you're saying, oh, I can see that these aren't counterexamples, clearly then you can check those off and then move to ones where it's more complicated. So now that we have this idea of we're interested in evaluating arguments for validity, and the way we do that is to look for counterexamples. In the next video, I'm going to actually go and look at some actual examples.